Okay, good afternoon, everyone. Welcome to this last day of TechEd, and welcome and thank you for staying this long. Thank you for making the long walk through the hall. We're going to talk about patterns and practices for running large multi-tenant software as a service services on Windows Azure, aka how it's made MyGet. So we're going to talk about the startup that me and a couple of guys are building and how we decided to go with which components of Windows Azure, which components we chose and why, and which obstacles we actually encountered during building that thing. So who am I? I am Maarten Bayou. I flew in from Belgium. And during my day-to-day job, I'm a technical evangelist at JetBrains. But at night, I am the co-founder of MyGet. I also run the Windows Azure user group in Belgium. And my main focus is on web development, so that's why I'm building web applications on Windows Azure. And actually, Windows Azure is really my big passion. You'll find me blogging about that. You'll find me tweeting about that. And next to Windows Azure, another passion is NuGet, on which I wrote a book. So if you want to buy me a beer, you can either buy the book or just buy me a beer. I would be happy with that as well. NuGet and Windows Azure combined is actually what we did with MyGet. So it kind of all comes together in this product we've built. The agenda for today, there's quite a lot on there, but you'll see it's actually not that much. Let's first talk about what NuGet is and what MyGet is. I don't know if you're all developers. Who's a developer here? Okay, most of you, which is a good thing. Who's using NuGet already? Okay, good, perfect. For those who didn't raise their hand, we'll quickly touch base on what NuGet is. Then we'll have a look at what MyGet is, and then we'll go into why we built this solution, how we built this solution, what worked, what didn't work, our architectures that we actually put in place, so we evolved the architecture over time. We have some multi-tenancy in there. We'll cover how we did that as well. And I want to end with some of the tough times we had in building this product. So tough times are always learning moments. So what we're going to see is some challenges we had, some downtime, some crashes, why they were caused, how we solved that, and why it actually happened. And you can learn from that as well. So let's kick it off. NuGet, MyGet. NuGet is actually a package manager or a dependency manager for Visual Studio. So if you're building your project inside Visual Studio, what you can do is instead of adding references, is adding NuGet packages. If you want to install a third-party package currently, well, not currently, without using NuGet, you typically go to the website, you go to GitHub, you go to Codeplex, you go to whatever site where something is hosted. You have to find the right download. You have to find all the dependencies that are required. Like, for example, if you want to install Hibernate, there's quite some dependencies in there. You have to extract them, you have to unblock them in your Windows. You have to add them as references. Maybe they're not the right target framework. So you have to basically think about a lot of things that are in there and a lot of things you have to do when installing that thing. Another example is Elma, for example. That's a logging framework or a diagnostics framework for ASP.NET applications. If you want to install this manually, you have to find quite a lot of assemblies to install into your project. You also have to modify your web config, add some configuration sections. You have to add some other settings in there as well, and it's quite a long process to do this. With NuGet, however, you can simply open up the package manager dialog, search for a package that you are willing to install into your project. You just click the install button, and NuGet will bring that thing into your project. It will also take care of dependencies. So if this package depends on other packages, NuGet will also install those dependencies together with this package, which is it's the best thing that happened in .NET in the past few years, I think, NuGet. It makes working with dependencies, working with third-party stuff way, way easier. Now, there's one problem with NuGet, and that is that there's only one gallery. So all packages are hosted on one gallery. And if you go to that gallery, it's on NuGet.org, you will see that everything that is in there is public. So if you, in your company, have some frameworks, maybe you have some components that you've written and want to reuse across different projects, what you will encounter is that you cannot actually post them on NuGet.org because NuGet.org is public, and unless you want your intellectual property, the things that you're building inside of your company, out there in public, you can post them there. But if you don't want that, you will require your own NuGet feed. And you can configure this in Visual Studio. And on the server side, you can either do it yourself or make use of MyGet, which is actually providing NuGet feeds as a service. So you can just go to the website, you can create your own feed, you can upload packages there, you can upload all the dependencies, you can keep track of all the versions that are there, you can have user management, so you can users who are allowed to post packages to that feed, but other users maybe only can download packages from that feed. You can invite users, you can deny access to feeds, and so on and so on. We have quite a lot of features that are there. So, the main reason why MyGet was created is to safely store your intellectual property instead of publicly announcing it on the NuGet.org website. Another things you can do is, creating packages. What you typically do is you create them using NuGet, using the console, or you create your own package by zipping up everything in the correct format. And it's kind of hard for a lot of projects. Well, what we do, we have a build service as well. So you can simply link your GitHub or Codeplex or Bitbucket account to MyGet, and we will do the packaging for you. So it will install or it will create packages from the source code that you have. Security, we can have multiple users use with different access levels to the feed, to the packages on that feed. We have activity streams, so you can see what your team members are doing on the website and so on. We also have symbol server. So if you upload your packages to MyGet and you have symbols packages containing debugging symbols, for example, what you can do is link your Visual Studio to that symbol server as well, and while debugging, you will actually be able to step into the sources of the assembly that you're currently running, which may be coming from such a package. We also have some analytics, so you can see who created what. You can see the download count. You can see basically a number of statistics that are available with regards to your packages, and there's more coming on that site. I'm doing this not by myself. I actually have a couple of nice and smart team members, Xavier and Yves, and you can find us on Twitter, and you can also find MyGet on Twitter as well if you have questions or you want to come into contact with us. Now, how we started, that's actually quite interesting. We didn't start off with MyGet as a product. So the real begin was, I think, somewhere in the beginning of May 2011. So actually, we became 2 years in the past month. The thing was, I created a blog post on my blog around using dynamic WCF service routes. So the idea for this blog post was to create a component where you could plug into your ASP.NET routing the fact that you can host your WCF service and use routing in there. So you can have multiple URLs going through a specific route, have them arrive into your WCF service, and basically take in all the parameters that are coming from the URL that you are using there. So that's the real begin of MyGet, even before we actually conceived the product there. Then, around the same time, NuPack was introduced. And NuPack is one of the prior names for NuGet. And NuPack at that time was using OData to host their feeds of packages. So the idea there was, okay, OData is based on WCF. It's kind of WCF. It's using the same core engine and things like that. So what if we could take this approach of having multiple, actually one service with multiple routes pointing to that service with an OData feed? We could create multiple feeds. The interesting thing is that if we can create multiple feeds, we can also create multiple feeds for NuGet or NuPack at that time. So we exchanged some ideas, and during a conference, we basically prototyped something, which then was online, I think end of May. So we're actually 2 years by now. So we created MyGet, and back then it was simply just a list of favorite packages. So you could create your account, you could select the packages from NuGet.org that you really like and you want to have in your project, and basically expose them over your own feed hosted on MyGet. So we started adding features and so on, and we used some technologies there. Windows Azure was new, and we were kind of like, we want to try Windows Azure. What is this? What this can mean for us? And we started using Windows Azure there. Now, being cheap, well, there's actually a joke going on in Europe. I'm from Belgium, and the country above us, the Netherlands, we call them cheap. It's actually probably in the other way. But we were being cheap, and we wanted to have an inexpensive way of hosting our data. So what we did was we used table storage, because that was, compared with SQL Azure at the time, way, way, way cheaper. Also, we wanted to host packages, so we decided to go with blob storage for that. Now, since you're all developers, I guess everyone has built their own login system in their life, and probably a couple. Who didn't? I would really envy you if you didn't. So, everyone has to do that a couple of times during their career, and we decided not to do that and make use of Windows Azure ACS. Again, this was a very new platform at the time, and ACS looked really promising to have social logins and Microsoft accounts, Windows Live back then, Facebook, Google, and so on. We decided to go with ASP.NET MVC2 and the Managed Extensibility Framework to basically tie everything together there. So I actually, before the session, I went into our code base and into our source control repository, and this is our code from back then. So this is a list of feeds, and what we basically did is, in the controller, connect to table storage, get everything there based on the partition key, and then throughout our code, we had different sub-queries where we were filtering on, is this feed visible or not? So we were doing this all over the place, basically. We didn't have repositories, we didn't have anything like that. We just created a very simple prototype because we didn't even think there was really a need for MyGet back then. This was also an interesting one I found. It's the best logging and error handling method ever, I guess. The good thing was we were consistent, and everywhere we did this, we had this same code comment in there. So we were always catching exceptions and using the same comment, which actually made it pretty easy to afterwards discover every location where we were doing this. So it has advantages doing this. Best practices? Not really, actually. So you saw the code. We didn't have any exception, real exception handling apart from just catching the exception and ignoring it, basically. So the architecture, we were running on one instance on cloud services. So again, we were cheap. We didn't think there were people going to use our service. So we just deployed on one machine. If the machine goes down, the service is gone. Storage accounts, just one storage account containing all the feeds, containing all the user data, and so on. And then, of course, Windows Azure Access Control Service. Now, what we did not know at that time was that users would come. Actually, while we didn't really think there would be a need for something like this, we grew from like 5 feeds, like close friends on Twitter who decided to give it a try, to 70 users, to 70 feeds in like 2 weeks. And then after that, feeds were being created on and on. So we were thinking like, yeah, okay, users are coming, interesting. Data would come as well. There was actually, apart from just favoriting packages from NuGet.org, we also allowed uploading your own packages or uploading packages that you were creating somewhere. Now, the interesting thing is that some open source project, and I can say the name because it's open source, .spatial, they are doing all kinds of things with spatial data and spatial data types, and they were pushing all their continuous integration packages to MyGet. So one user, .spatial, pushed like 1,300 packages worth like 1 gigabyte of data. Some others also started pushing their continuous integration data, their continuous integration packages to MyGet. And then some others were like just copying NuGet.org to have a copy of NuGet in their own feeds. So we didn't optimize anything. All packages were stored like 20 times if there were 20 feeds. Using the jQuery package, we had 20 copies of jQuery on our storage. So users started to come, data started to come, and we were quickly like drowning. The architecture was really bad. So it was resharper time. And we did some refactoring there, quite a lot actually. The code you saw earlier, where we had controllers just going to the table storage directly, we started creating repositories. We introduced some services. The services would be used by controllers and so on. We're using all best practices that we were using in our day-to-day jobs as consultants back then, and basically creating a decent application out of it. Because before it was just a proof of concept, a simple prototype that we created there. We also decided to go to 2 instances. Users were making use of it. We actually saw in the data that there were companies also making use of MyGet. So we were thinking, okay, even though it's free, and even though we don't know if we will continue this product, we will probably want to be running on 2 instances because we also didn't have any disclaimers or service levels or some stuff like that. So we wanted to avoid going down, and our brilliant idea for not going down was, let's scale it out to 2 instances. Probably not the best approach, but still, at the time it looked okay. We also became a startup. So actually on Twitter, some guy said, I want to pay for this service. I'm using this on a day-to-day basis. My developers are making use of this. So he was like, where can I take my money? Where can I pay you? So we decided, okay, let's maybe think about a business model around this. While we were thinking about that business model, the usage kept going up. People were pushing more and more data. We also saw a lot of users were both in Europe and both in the US. So it kept growing, so we had to do something there. And we were thinking again of restructuring everything there and came to this first architecture for our application. Now at the code level, we had some projects, which was a web project running the websites. We had the services in there, we had the repositories in there, we also had the data in there. We had a decent data layer going to storage. And also MyGet core containing some extensions containing the dynamic WCF routing and things like that. Quite a traditional architecture, I think, something you will see in a lot of projects, and we thought it was awesome. We were using best practices. We were really awesome because we were using layers in the application. And it looked like a typical business application, like having layers, having decent separation of concerns. So we were like, yeah, we're awesome, and this product is awesome. Now, those best practices we were thinking we were using, are they actually best practices? Layers, okay, you don't get spaghetti code, but it's more like lasagna coding. So you have layers in there. And maybe that's good, maybe not. Also, the fact that we had a typical business architecture with repositories, data layers, and basically doing the same stuff a couple of times in every layer, it proved to be very inflexible. When we wanted to create a new feature in there, it proved to be time-consuming to do it. Add a column to a data type, and you had DTOs on several layers, meant that you had to add that column through like 6 classes or something. So it wasn't that flexible to work with and create new features. At the infrastructure level, our architecture was looking quite okay, I think. So we were hosted in the Europe West data center back then, and we were also hosting one web role in North Central US. Because we had users in both Europe and the US, we decided to go with a geographically distributed application there. So we had a web role sitting in Europe, we had a web role sitting in North Central US. All the storage was in Europe, so the US service was connecting to the storage account sitting in Europe. We had ACS in Europe as well. And on top of all that, we were making use of Windows Azure Traffic Manager. You see, we had this brilliant scheme, again, being cheap and trying to be inexpensive, of running on 2 instances, but instead of using the load balancer in Windows Azure, we would use Traffic Manager, kind of like a load balancer. We were thinking if the web role in Europe goes down and we configure Traffic Manager that it will fail over all the DNS requests to the US, that all our users would immediately be using the services from the US. Sounds good, right? I think we reduced the time to live in Traffic Manager to 30 seconds, and we actually did some tests there, and it kind of worked. If something went down in Europe, Traffic Manager would, within 30 seconds, be available and hosting our websites in the US. So that was really interesting, and we thought, yes, we're safe, we are redundant, everyone can use our application, and we will never go down this way. With regards to packages, we were also thinking one of the main use cases for MyGet is consuming packages as a developer or on your build server or things like that. So we wanted to have those packages close to our users. And what's closer to your users than a CDN? So we decided to push all those packages to the CDN and have our users consume those packages from the CDN as well. Awesome. The data centers were close to our users. We had centralized storage, so we didn't have to think about synchronizing data, replicating data, and so on. Packages were on the CDN, so we had fast throughput. And with Traffic Manager, we had DNS failover in case something went wrong in one of both data centers. It wasn't that awesome, actually, to be honest. Data centers close to our users, well, are they? We were seeing users coming from different regions in the US, different regions throughout Europe, and we decided, well, maybe those 2 data centers are close to our users. But are they? I mean, are they on the network topology really close to our users? We actually didn't know there. The fact that we had this centralized storage in Europe meant that every request coming in the US web server would have to connect to storage in Europe, which was quite time-consuming. Like, for example, we didn't have any optimizations there with regards to, for example, getting the list of feeds. We didn't cache it in the US, so every time you wanted to get the list of all your feeds or all of your packages, you would have to connect to storage in Europe, which means latency. And latency is really killing your application. So it was killing us as well. So if you were using MyGet back then from the USA, I think some pages, if you had a decent amount of data, took like 10 seconds to load. And I really hate it when a web page takes 10 seconds to load, but we were there. That was the case for our website as well. The fact that the packages on the CDN were there for faster throughput also meant that we had some other issues. We didn't really think about putting a time to live on there, so like caching headers and things like that. So if a user would update a package, it wasn't immediately the updated version that was available from the CDN as well. So we had some issues there. We also faced some downtimes on the CDN back then. The CDN wasn't that stable, it proved, so sometimes a package would be there, sometimes it wouldn't, and just give 404 errors that it was not found, even though it was on our storage, and you could actually access it on storage. Also, this DNS failover, well, we tested it on our machine, and you know everything always works on your machine, right? We tested it on our machine, and it worked, but apparently not all ISPs across the globe are respecting DNS time to live as well. And actually, Xavier, he had an ISP back then in Belgium, and he also did some tests there, and they were keeping like the DNS records for 1 day, even though our TTL was only 30 seconds. So this didn't really prove like a good architecture. But we persisted. We thought, well, in the current architecture, let's optimize everything, and let's try making it a better product. So we added local caching in the US. So you still had the central storage in Europe, but every time you would get your list of feeds, you would just cache it in memory in the US. So the next time you would access that page, it would go faster because it was still available in memory. We also scaled out. 2 instances in Europe, still only 1 in the US. So 3 instances in total for this application. And even though 1 server went down in Europe, we didn't have those DNS failover issues and so on. But still, synchronizing data between all the locations kept being slow. Making sure that the cache was populated in the USA also was like a nightmare. We didn't really know when to invalidate cache, when the cache was stale. It was a mess, basically. Also, the CDN kept having issues. Actually, at one moment, we decided to just ditch the CDN and have users access blob storage directly, even though blob storage would then also be in Europe, and the data would not be that close to our users. We also saw that of those 3 instances, if you looked at the CPU usage on those 3 instances, we actually saw that there was only like 60% usage of CPU across all machines, which meant like 20% on each instance. So we're like, okay, we're paying 3 instances, but only using 20% of the CPU that's sitting there. So not that ideal, to be honest. Also, we were growing. So we came up with this business model of having like a freemium approach where you have a free plan, where you have paid plans where you can go into and so on. So users started using that, and for the paid users, we wanted to make sure that we were still up and running. Also, we saw that just having a freemium model with smaller plans is like we want to get rich at some point in time, right? So doing that with those small plans would take forever, and possibly our grandchildren would be able to profit from this approach. So we were thinking, okay, let's also target enterprise tenants, who will basically have their own copy of MyGet, and which they can completely configure, in which they can manage their users, in which they can manage their storage, and so on. Now, introducing this multi-tenancy also meant that our architecture was becoming quite complex. We had to introduce this notion of having a tenant, and we had to do it across all layers. Also, the caching and the synchronization became quite complex, because we decided that every tenant would be located on its own storage account in Windows Azure. We also wanted to have a different CDN for every storage account, because we actually re-enabled the CDN back then. Which meant that we were having the same issues with the CDN again, but a couple of times for every customer, so not that ideal. So again, we thought, refactoring time. So our second architecture, and this is also still our current architecture, looked quite different. We basically took the approach of looking at our workloads. Instead of just building the application and thinking about all the things we've learned throughout the years building applications, we were thinking, let's have a look at the workloads and build the architecture up from that thing. So we saw that we basically had three workloads: managing feeds and packages, downloading packages, and the builds, of course, since we introduced build services as well. Managing feeds and packages is not something you typically do daily or the entire day. So we decided, okay, managing packages and feeds, it might be nice if there's not that much latency, but like 1 second page load times, it doesn't really matter. So we decided maybe we can just move everything of the website into Europe. Downloading packages still was quite important. That's something developers do, and I'm a developer myself, so I know how frustrating it is if you have to wait too long for a download to come in. So we decided to have the packages closer to our users, which means if you're on the public tenant, if you're on the freemium model, you will still have your packages located in Europe, and you will be downloading packages from within Europe. If you're an enterprise tenant, we actually give you the option to select where your storage should be located so that it's closer to your location and you have faster downloads and faster throughputs. The builds we were doing, it doesn't actually matter where we do that and how we do that, because you're only interested in the results, namely the packages that come out of the build. So we decided to move that into Europe as well, to not have build servers everywhere. So our second architecture at the infrastructure level was something like this. So we're still mainly based in Europe West as a data center, and we are running some web roles there. The web roles do basically a lot of things. They do the public websites, they serve the feeds, they make sure that every time you download a package, they include something that we should increase the statistics and log the download and so on. Those web roles are making use of one storage account, and that storage account contains only tenant information and our storage queues, and I'll come back to the queues later on. If you go to the website and you go to the standard, regular, freemium kind of websites, we will basically match the URL with one of the tenants in storage, and based on the tenant, we will contact the right storage account for that tenant. So if you're on the public tenant, you will go to a storage account for that tenant. If you have your own enterprise tenant, you will be located in a different storage account. You will see that we're still using Windows Azure Traffic Manager, even though everything seems to be running in Europe West. We decided if something goes wrong in Europe West, we want to be able to quickly fail over to a different data center. Well, quickly is relative, of course, but we want to make sure that after a time, if Europe West has some serious issues, we can just deploy something in one of the other data centers and at least have Traffic Manager make sure that the DNS is okay. So we don't have to think about that. We can just deploy and everything will basically, all the traffic will automatically go over into one of the other data centers there. Still using ACS as well. With regards to storage for tenants, if you're in the US, if you're in China and you want to make use of MyGet as an enterprise tenant and you want your own storage account, you will be offered the choice to have your storage account closer to you, so you can actually have faster throughput on all the downloads there. We have a secondary storage account in Europe North, which is basically our backup storage. So all those storage locations we have across the globe, they're all being backed up into the Europe North data center. Why do we want backups? Well, there's still human errors, sometimes on our side, sometimes on our customer side. And if they, for example, deleted a package and they want to restore it, we can fetch it from one of the backups. Why didn't we put those backups in Europe West? Because that's also the location where most tenants are currently located. Well, even though the bandwidth cost is there of pushing everything up to North Europe, we still want to make sure that if West Europe fails for some reason, we can still access our backups and maybe restore from backup if really needed, if there's really a problem in the platform. Our build servers are also in Europe West, so they're basically just running infrastructure as a service. They have an agent installed which fetches sources, creates a package from that, and pushes it to the website. With regards to code, we decided to remove a lot of the layers in there. So we now have our web application and we have MyGet core. in which we still have repositories and we still have some of those things, but we decided to dramatically reduce the amount of overhead in doing something, in adding features and so on. So we decided to step back and not go really enterprisey in terms of layers there. MyGit core contains also all methods to connect to storage, connect to the storage account to decide which tenant is there. So basically all logic is in there, and the website is simply using that to present everything to the user. Now our first architecture was scaled across the globe, and it was very synchronous. So we were waiting for storage to respond to the results and things like that. We were doing synchronization and so on, and that basically proved very bad because of issues with latency, synchronization, making sure caches don't go stale, and so on. So we came up with the idea of an event-driven architecture. Well, not really an event-driven architecture as you can see them in the books, but we decided to borrow some concepts there that made sense for our solution. And we are using things like commands and events. So whenever in our application you want to do something like storing the fact that the user has downloaded a package, we have one ground rule. If that's only one storage operation, we do it directly, because pushing it to a queue or pushing it to storage, it's the same thing. We have to open up an HTTP connection and post something there. So if it's only one operation, just do it. If it's more than one operation and you don't need real-time feedback of the operation, throw a command on the queue. So what we do there is, for example, if you do a login and we want to basically update when you last logged in, and we want to update some views that we have on that information, that's a number of operations, so we create a command for that. We put that command on a queue, there's a worker listening, and that worker is consuming the queue and making sure that this command is being executed. All actions end with an I event. So whenever we do something in our code, and whenever an action happens, like deleting a package, at the end of that operation, we get a package deleted event. And we consume that event as well, and those interested in that event can respond to that event. Handlers are basically parts of the code that are being loaded by this worker role, and they will check all those commands and all those events that are in the queue, and they can do something. One important thing there is that all handlers are idempotent, which means that whenever they start an operation and they fail during the operation and they come back in the queue, they resurface, we want to be able to run that operation again and again and potentially again in case something is wrong there. So we are not making use of any states that we depend on and which may conflict if we run the same operation a couple of times if needed because of failure that's inside of the code. So an example, a login. That's basically two operations, namely reading the profile. We want to make sure that the password is actually known. But the actual login is just doing a write setting the last login date. So we don't have an I command there, but we do finish this operation with a user logged in event. Just to make sure if anyone in the code is interested in this event, we can subscribe to it and respond to it. Another example is changing the feed owner. So every feed in MyGit has an owner, and you can delegate access to someone else. You can say, I no longer want to be the owner there. I want to move this feed to another user as the owner. So if you do that, that's quite a lot of operations. We have to read both user profiles. We have to check all the access rights for both users. We have to change those access rights. Since we are not hosting our own symbol source, but actually using a third party named Symbol Source to host our symbols packages, we have to update the privileges there as well and make sure that the owner of the feed also changes on this symbol server. So really a lot of operations going on there. So what we do if you change the feed owner is we put a change feed owner command on the queue containing this owner delegates access to this feed to that user. So basically 3 properties there. Then we have a handler basically processing this command. And once that command is finished, we throw a feed owner changed event to the queue, to which other subscribers can subscribe afterwards. So an example for this change feed owner, we create a command there. We have a handler, so the change feed owner command handler, listening to those commands. It processes everything, and after processing, it publishes a feed owner changed event to the queue. This feed owner changed event is then consumed by our symbol source handler, which is our integration handler with symbol source, and it sees that the feed owner changed, so it knows it has to push updates to symbol source as well. We also have an activity log, so you can see whatever happens on the website and whatever happens with the streams. So this activity log handler basically takes in every event and just logs it so you can consume it through the website. Going back to the symbol source handler, it will also publish a symbol source events completed something on the queue. So in case we need to do something after that or we are interested in this information, we can subscribe to this thing as well. And this architecture actually works pretty well. The gain of doing this in our architecture is that we can now run on less instances. Doing this actually made the load on our servers, because of the asynchrony there, that the load on our servers could go down. So we are now using 20% of our CPU across both machines, so on average like 10% per machine. We have a lot of flexibility there and an easy way of implementing new feature. For example, this activity log was something we didn't have originally in the website. Now we decided, okay, we want to create a new feature called activity logs, and we want to basically have everything like the user changed his profile, he uploaded a package, he deleted a package, he created a feed, and so on and so on. And we're thinking, okay, do we have to wire this logic everywhere into this application? Do we really have to go into every write operation and also write something to the activity log? No. We were already throwing events on the queue, like for example, when a feed owner changed or when a package has been downloaded or a package has been uploaded. So we simply created a new handler, subscribing to all those events we were interested in, and we are storing those in table storage. Feature completed. This feature literally was written in, I don't know, maybe 2 hours, including the UI work. So it's really easy to build that feature based on the fact that you have those events there, and you can respond to those events. In terms of storage, we are still using table storage as our storage system. So we are not using SQL Azure. We are not using a relational database. Why not? Why should we? I mean, the architecture was there. It has been there for a while. And since we are using events, we can have things like duplicate data and so on. So imagine we have this, imagine that's actually a feature we're currently building. Imagine we want to have analytics. Who downloaded which package using which client, and so on and so on. If you want to store that, you can just dump it into a table. That's perfectly fine. But if you want to consume that, if you want to filter that, what's the #1 requested feature for table storage? Anyone? Secondary indexes, indeed. You don't have secondary indexes. So if you want to query table storage for example, I want to know which user from which country has downloaded packages using this client. That's a difficult query on table storage because you cannot really use secondary indexes to consume that. So using these events, we can just subscribe to the fact that something has been written into our logs for those statistics, and then the handler for that thing can just copy that data into another table in which the data format is really structured towards that query. So we can optimize our data there. If we want to change that data, we can just subscribe to it and replicate it across multiple views. So we are basically creating views on our own using this event-driven architecture. We also found that table storage isn't that bad with regards to performance, and you actually have some sort of secondary indexes today. So imagine you want to store packages for a feed, and those packages have an identifier and a version. So you basically have 3 key properties there. You have the feed name, you have the package ID, and you have the package version. If you want to store those and you want to be able to query them easily, there's a couple of things you can do. You can concatenate everything and make it a partition key or the row key and query on that. Perfectly fine. We decided to go with a table per feed. So if you have a package in a feed, the table name is actually also the feed name. So if you want to search for a specific feed, we already know it's that specific table. If you want to search for a package in that feed, well, we can simply search the package ID in that table we know. And the package ID there is the partition key. As the row key, we chose to have the package version there, so we can just fetch all packages with a given ID and then use the row key to filter on those things. We can actually also use the row key to order based by version. So it's really easy to do that in this way. So you don't always have to create your own views. You don't always have to store all the data multiple times in your project. Okay, so storage. You may have tested this, but reading more than 1,000 rows from table storage is slow. It may be fast, but in general, when you do this, like when you have like 1,500 or even more rows in your tables, it's quite slow to fetch them. The reason why this is slow is that they are all partitioned, they are paged actually by 1,000 rows. So if you want to fetch all entities there, you have to do multiple requests to get all those entities. Then if you have all those entities, you have to deserialize them and make sure you have .NET objects which you can use and so on. So in the example of this open source project pushing a lot of packages to a specific feed, we actually have a lot of rows there. And we also noticed in our previous architecture that when they were querying their feeds and looking at the packages that were there, it really took sometimes 20 seconds to fulfill that request, so that's not ideal. So we decided to do some caching. Having this list of feeds and having this list of all the packages that are on such feeds is something that you want to use. You want to be able to view all the packages that are there, and you want to be able to click through to a specific package and so on. So we decided to cache those. Now back then, there was this caching service, this dedicated caching service on Windows Azure, which then suddenly disappeared and changed into some other caching service. But we decided to not go with that caching service because we did some tests back then and it wasn't that ideal. The current one is, in fact. But back then, we didn't have the opportunity to make use of this new caching system. So we decided to come up with something on ourselves. If we have to download more than 1,000 rows, actually we do it for the list of packages continuously, what we do is we fetch all those things in such a handler. So whenever we post something to a feed, it goes into an event on the bus. The handler subscribes to the event that a package has been added, and based on that, we create the cache. So whenever something happens in terms of packages, we subscribe to the events, and we download all packages. In the backend, if it takes 20 seconds to get all this data from table storage, it doesn't really matter. We fetch all those entities, we serialize them into JSON, and we store them as a blob. These blobs are typically like a few kilobytes in size. So if you want to query your list of packages currently, what we do is we download the blob from blob storage containing all those packages, and we just list it. One request, so one HTTP request, and fairly small because it's only a couple of kilobytes typically per feed. So that's our approach to caching there. We are currently investigating the new version of caching to move everything there, but that's the solution we have there. How do we update caches? Well, I already told you we just have this events on the queue, we listen to the queue and to that event, and we update our caches. Okay, multi-tenancy. That was actually an interesting one to build into the application. How would you approach multi-tenancy? There's a couple of ways you can do this. How do you do this in your code? What you can have is you can have a URL, and based on the URL, decide which tenant it is. And for every call you do into your backend code, always pass this tenant ID into your backend code. Now, we had a lot of code, and we didn't want to refactor everything there to bring this one parameter in there. So the tenant, just like your requests, like your response, like your HTTP contexts, and your current user is a context. So the tenant is a context. Every operation you do on the website happens within the context of a tenant. So potentially, whenever a request comes in and a response goes out, this tenant is different. So there's no real way of knowing which user is bound to which tenant continuously. Luckily, we have dependency injection containers which have lifetimes where we can just figure out the tenant once per request based on the lifetime of the container and then use that tenant context throughout the application. So that's what we do actually in there. So when we want to resolve a tenant, actually everything that is bound to the context of a tenant implements or makes use of this iTenant context instance. On this context instance, we have a tenant. What information is in there? Well, the host name, the billing plan, how much he pays, who are the contacts, and basically everything related to that given enterprise or that given public tenant we have in MyGet. Then we register this thing in our dependency injection container, and you see that we are registering there a request tenant context. So for every request coming in, based on the lifetime of this dependency container, we create this new request tenant context object. This request tenant context object then just resolves the contexts of the tenant based on the URL. So whenever a request comes in, we just map that URL to a given tenant coming from our tenant table. And we then simply return that tenant. We return an iTenant context, and throughout the application, we can just query our dependency injection container for this tenant context because it lives throughout the entire request. We do the resolving every request that comes in, but throughout that request, we don't have to do the resolving again, and we can just query our DI container there. Next thing we have in there is Windows Azure Access Control Service. So the reason why we chose for Windows Azure Access Control was we don't want to create another login system. That was the reason back then, and we are really happy we chose this solution because, well, over the course of time introducing those tenants, we actually have multiple applications if you look at them. We have our www.myget.org, we have our staging, we have our local host where we develop. We have customers on there who all have their own domain name under myget.org. They all have different identity requirements. Some of our customers do not want a Microsoft account or a Google account. They only want their own ADFS accounts to be linked to myget. Some tenants want Google, some tenants want GitHub. Not everyone wants all of those identity providers. We use all the identity providers, but not every tenant will do that. Will do this. So if you want to link those things together manually, you will end up with something like that, a big bowl of spaghetti. So ACS is basically your solution to identity orchestration, as I like to call it. So we have one tenant, we have a couple of tenants, and they all make use of Windows Azure Access Control to perform the login. Fun thing there is, all those tenants, all those applications only have one trust with regards to identity, namely ACS. And in ACS, we simply look at the host name from which the request is coming, and based on that host name, we give them another list or a different list of identity providers that they can make use of. So that's kind of useful because we don't have to care in our application about which identity providers will be used throughout the process. Azure Access Control takes care of that. We can configure this. If a tenant decides he wants to add Google accounts, for example, we can simply enable the checkbox in ACS, and we don't have to change the actual application code or the application configuration there. We have no more user registration. Well, we do have, and I'll explain later on. We have one single trust relationship, so we trust ACS to do all our identity stuff, which means less coding. Whenever a new identity provider pops up that we want to support, we don't have to write our own codes to implement this. Well, if ACS supports it, of course, but we don't have to think about all of that. We can simply make use of ACS, and we don't have to think further within our application. Every tenant can have their own ADFS plugged in. We can plug in other identity providers as well. And actually, we had quite a lot of requests of users asking for logins through GitHub, through Stack Exchange, through LinkedIn, and so on. So we built those for myget, but we simply linked them in ACS. So myget links to ACS, which links to myget, which then links to GitHub. So that's basically the story we have there. Fun thing is, we are actually getting quite tired of maintaining those things within our myget code base, so we decided to pull them out over time, and that's actually something we're working on. socialsts.com allows you to plug in LinkedIn, Twitter, Microsoft accounts, but in a good way. We have Amazon account support and so on in socialsts. So all those identity providers are basically pulled out of myget, and you can now use them in your own application as well when using ACS. So that's kind of a spin-off we have from myget. One little trick we do, if you use Windows Identity Foundation, typically if you use this wizard connecting it to ACS and so on, you will see that you have some audience restrictions. So Windows Identity Foundation will only accept responses if the audience for the response was a given URL, which is typically your application URL. Now the fun thing there is those are by default, they are defined in your web config file, which means whenever we add a tenant, we actually have to go into that web config file and add the URL for that tenant because we want to accept tokens for that tenant as well. Now you don't want to do this. You do not want to redeploy every time you have a new tenant onboarding. So what we do is this thing at startup of the server basically. We just get our configuration from Windows Identity Foundation. We check our allowed audience URIs that are coming from the data store, and that's basically all the host names we have for our tenants. And we add them to the Windows Identity Foundation configuration. I actually added this slide because one guy asked me this on Twitter, so there you go. We also had some tough times in the process, and really tough times like downtime. But tough times are typically also learning moments. So we actually had 2 major outages on MyGit, and we learned from them and what happened. And I hope you can learn from them as well. First one was last year, July. We saw on Twitter that some users were complaining about downtime. And we were like, downtime? We all have a smartphone, so we open our smartphone, go to the website, and we see the website is still loading. We didn't get any SMS messages alerting us that the service was done. We didn't see anything special in our logs until half an hour after the first tweets we saw and after the first support emails that came in. We started receiving SMS messages saying the site is up, site is down, site is up, site is down. And that little image there where you see all those red stripes were actually those up and down cycles that were happening. But what's the cause of this downtime? Why is this behavior there? We were suspecting our new multi-tenant architecture we put in place. Another thing we did back then was enable storage analytics. And since that was a new feature back then, we were thinking, well, we have an SLA on the amount of transactions you can do, but is Microsoft actually including storage analytics in those transactions or not? Because we had some quite aggressive logging there on storage, and we're thinking maybe we were getting throttled based on enabling this thing. Or maybe it was our multi-tenant architecture. Who knows? If we looked into Elma to get some of the logs from the web server, we saw we actually were receiving error messages stating that we were getting throttled on storage. In our queue, containing all commands and events and so on, we also saw that we had quite a lot of unprocessed commands that were in there, and they were not getting processed. So they were just sitting there and nothing was going through. So we were really, really getting nervous about this thing, and we started investigating. And we found out, by the way, you can find the full story on our website as well to see what went on there. We found out that one simple piece of code dating from back when we were a proof of concept actually brought our entire website to halt. We found out that at the package level, we implemented a get hash code. And for some reason, some user was pushing a package to MyGit, and that package had the exact same hash code in our implementation as another package on that user's feed. Having those 2 packages there and using table storage, using the data context there, this same hash code basically triggered an exception. Because in OData, the client, if you fetch an object or you add an object to your object context and you add another one and they have the same hash code, it will say, hey, I'm already tracking this entity, and throw an exception. So you can now laugh and say, what? Your entire website crashed because of an exception and because of a faulty get hash code implementation? Yes. But the exception wasn't really the big problem. Well, the hash code, of course, was the problem, and the exception was what's happening. But something else was happening because of this. We actually were retrying every operation for every exception. You've been to Windows Azure talks before, and they always say, whenever an operation fails, retry it. We didn't really get a message back then, because you only have to retry transient errors. For example, if there's a network connectivity glitch, or something happens at the partition layer and it gives you an exception to try again later on, you have to retry those, but not every exception you get in your code. And that was actually what we were doing. So, 16,000 commands in our queue, exceptions being thrown, caused storage throttling. The fact that there was storage throttling while users were still coming in through the website, meant that users on the website were also experiencing throttling because, well, they also retry all the read operations there. The fact that those things were retrying and keeping the requests open much longer and consuming quite a lot of threads meant we were having thread starvation on our IIS worker threads. So we were still completely up and running. It's just that the data center was nearing a meltdown. So lessons learned from this thing, a simple bug can halt your entire application. A simple get hashcode thing and an implementation that you think is okay and has worked for the last year and a half is perfectly fine, but that small bug can actually bring down your entire website. Lessons learned, only retry transient errors. Our monitoring wasn't that great, and we actually had to improve monitoring, and we have improved monitoring in place right now. And we had some bad untested code, and we had to go through our code base to find occurrences like this and really have a closer look at the code we historically took from when we were just a proof of concept. A second huge downtime we had was this year, February 23rd. Who's doing Windows Azure and who has an application on Windows Azure? Who was not down that day? Okay. So you already probably know what happened back then. Well, Windows Azure had an issue, and globally. Not only in Europe, not only in the US, everywhere. Everything was down. That were our symptoms. We were seeing furious users on social media that were saying, MyGet is down, blah, blah, blah. We were also seeing furious users using the Windows Azure hashtag. So we were like, okay, this is probably not our fault, but maybe something else. So we went to the status page and we found that because of an SSL issue, Windows Azure globally failed. So can happen. So what do you do about this? We had some considerations there, and because of the fact that this was related to an SSL bug or an SSL issue, you couldn't access storage using HTTPS, because if you access storage using HTTPS, you want to have a valid certificate, but the certificate was no longer valid, which means that your application using storage over HTTPS will fail because of this failing certificate. So we're thinking, okay, maybe we should consider going to HTTP. We didn't choose to do that because we want to have secure connections and no man-in-the-middle things in the data center. Even though we think they will never happen, you never know. We also think that probably this thing will never happen again. I hope. So that's why we are not changing HTTPS to HTTP. Windows Azure globally going down really impacts us. We still have this backup, we still have this failover to other data centers if we want to do this, but we cannot do this if Windows Azure is down. So if Windows Azure is down, we are down as well. So to solve this, we were thinking, okay, if we want to fail over to a different cloud provider or to our own infrastructure, that would cost a lot of money to keep up and running and a lot of effort, and we decided not to go there. What we are considering, though, is moving all our backups off Windows Azure to make sure if something like this happens again and we have a longer downtime there, that we can restore the application somewhere else using the data from our backups, which we can then still access from this other provider, hopefully. Another lesson learned is features. If you introduce new features, strange things can happen. So a couple of months ago, we introduced retention policies. So basically, if you are using MyGet and you are pushing continuous integration packages to MyGet, maybe you do not want to keep all those packages, but only the latest 10 or the latest 20. And that was actually a feature request we got, and a lot of people were asking for this, so we implemented this thing. And when we introduced this thing, it seemed to be a success. Everyone, literally everyone, enabled this feature on their MyGet feeds. And we had a lot of feeds having a lot of packages, and they immediately triggered a chain reaction of commands on our queues saying, please delete this package, because you want to comply to the retention policy and only keep those latest 20 versions. But if you have 1,000 packages in your feed, and you have quite a lot of feeds with 1,000 packages, you get quite a lot of messages on your queue. So introducing this feature basically meant that our entire queue was being fire hosed with all the data coming in. So we had 3+ million commands in our queue, and everything was still running, but it was just really slow because our workers couldn't cope with all the load coming from that queue. So the solution to that was just scale out. So we scaled out to 20 instances for a few minutes. And after those 20 minutes, this thing solved itself, basically, because of the architecture. But we learned that the next time we are going to introduce a longly awaited feature, we will probably do this a little bit more selective and use things like feature toggling. So like only ship this feature to 100 users and not to the entire user base. Or maybe have invites or something like that, but not to everyone at once because we want to avoid this thing. Of course, we can scale, but feature toggling seems like a better approach there to solve this. But overall, even with those 2 huge downtimes, we actually do better than the SLAs that are given on Windows Azure. So it's quite easy to run on Windows Azure if your architecture is okay and able to handle all these things. So you see the February issue there in the uptime numbers as well. Some more things I want to tell you. Who's considering doing a startup or working on some idea? A couple of guys? Okay. There's some interesting things related to what your business requirements are related to the technological view of your product. We are constantly being bitten by the fact that we are developers. What do you do as a developer? I have this cool idea of starting things like build services. I'm going to fetch sources from all kinds of open source providers. I'm going to create builds and push packages to the website. Awesome, let's build it. You start coding, you drink some beers, you drink some Red Bulls, and a couple of hours or days later, the feature is completed. You push it online, you blog about it, you tweet about it, and users are seemingly liking this feature. And then you start thinking, okay, but now we have some VMs running, and we are not getting any money for the fact that those VMs are running. So you have to come up with a revenue model there. The fact that we typically do not think about revenue models up front also means that we have to do a lot of refactoring to get all the metering in there, to get all the data points we want to gather to apply our business model there. So lesson learned from all those features that we've implemented there is think revenue early on and build your code based on that revenue stream that you are expecting there. That's a really important lesson we learned from this thing. Also, if you're reading the Lean Startup, for example, everyone founding a startup is saying, track everything, measure everything, test your assumptions. And that's what we actually do as well. And we decided not to build our own measurement system. We decided to go with Google Analytics. And basically everything you do on MyGet is being tracked, not at the user level, but we're just measuring which feature is being used, how often is it being used, and so on. We do this using this NuGet package. That's actually something we put on NuGet. So if you want to use this, feel free to install it in your code as well. And we can get something like this. We can actually correlate website visits with features that are being used. But all features, you see them below, are listed as events on Google Analytics. So you can see there's quite a lot of features in there. This is an older screenshot, but you see a lot of things in there. There's quite a lot of information in there. You see that the number one feature being used there back then was traditional logins. That was our name for the fact that you used a username and password to log in. So we actually used ACS to not build our own user registration system, but we did have to add 2 columns where you could add your username and your password because Visual Studio doesn't support using ACS within NuGet, so we had to have a username and a password if you want to consume a protected feed. So we had that in there. But we saw that a lot of users were actually using this traditional login method to log into the website as well, not only from within Visual Studio, but actually in their browser. So from this information, we learned that we did have to write yet another user registration system because people seem to like this. We actually contacted some, so we actually got some requests on Twitter as well, where people were asking for this. We had this data, so we were thinking, well, let's build this thing ourselves. I saw a question there. Okay, so the registration system we built is just our own codes doing registration, creating the user, and we save our usernames and passwords in the backend. So it's not OAuth. Well, if you're using Windows Live ID, for example, to log into the website, we don't care. We just get an identifier from Windows Live, and we store that thing to link your user profile to that social identity. But with traditional logins, we have to store a username and a password because we have to validate it ourselves. So based on this, based on the feedback we got on Twitter, we actually noticed we had to implement this feature in MyGit. Second thing you see in there is that a lot of users are making use of our build services. So while that was a crazy idea when we first conceived it, people seem to like it, and we have to keep investing in that product, apparently. We also saw that feed discovery is quite popular. So we have an RFC for discovering feeds. The idea is that you put a meta tag in your website, and within Visual Studio, you can just say, discover the packages or discover the feeds that are located on this website. That's feed discovery, which is quite interesting because as a company, you can just host a website internally or externally, have a list of all your feeds there. In Visual Studio, say you want to discover feed packages from this specific URL, and you just have all those feeds registered in your Visual Studio. So that's an interesting thing. And when we blogged about this thing and we started making noise about this thing, we were never really thinking a lot of people would make use of it, but from this metric, we actually see that a lot of people are using this thing, so we will have to build on that as well. Something we don't see here is the fact that you can download your feed as a zip file. So we had some question of users asking, can I download all packages from my feed? And we were like, okay, that's quite an interesting feature because we think a lot of people will like to be able to download all packages from their feed. So we implemented this thing, put this thing live, and we actually were kind of afraid that when introducing this feature, people would start scheduling downloads for those packages and so on. And we were like literally afraid of the fact that this feature was being introduced because we didn't want to scale out because we just implemented this feature. But we were still thinking, well, downloading and zipping up all those packages still consumes some server resources. So we were afraid this was going to require scaling out, but we've never actually seen this feature surfacing in the top 50 of the features being used on our website. So our fear we had there was an assumption, and by measuring this, we proved our assumption wrong, basically. So measure everything, test your assumptions there. In conclusion, we've seen NuGet, we've seen MyGit, and how you can host your own packages and your own feeds on MyGit. You see that we didn't really start with the idea of starting a startup there. We just started with a proof of concept. We learned along the way about the platform, about Windows Azure. We learned that people would want to pay for our product, so we had to revisit our architecture. And we had to think about how to implement multi-tenancy to actually get a billing model and a revenue stream out of this product. But the most important thing we had during all those years building this product are those learning moments. The tough times, be it a total downtime or just something failing in the back end, those things are always interesting to know and to learn of and to build your product even better after that. And for those building a startup, for those building something, measure everything. Everyone has assumptions. Everyone thinks something will fail. Everyone thinks some feature will be popular. If you look at the metrics, you will probably see the inverse. So measure everything, measure your assumptions, and test them all. I see a question there, yeah. Okay, that's a good question. So the question was, have you come across documents from Microsoft helping you in deciding on revenue stream versus the cost of the platform? Actually, I have no idea if those resources are available, and I haven't seen them, to be honest. But what we did is we learn everything that is in the pricing calculator. You learn about the fact that storage is quite inexpensive, and we decided to go with that to have higher revenues on the other side. So you really have to learn the pricing model in order to be able to plan your revenue streams as well there. Another question.
Question regarding downtime in February. Have you claimed Microsoft for not fulfilling the SLAs?
Good question. Have we claimed during the downtime in February for not fulfilling the SLAs? An interesting thing there happened that the SLA, I think the total downtime was like 8 hours or something. So according to the SLA, we had to get back our 8 hours of resources that we weren't able to consume at that moment. So we were thinking about contacting Microsoft, but since it was a global outage and quite visible, Microsoft decided to just give every user of Windows Azure for that month, the entire month, not only those 8 hours, everything they consumed. So we actually didn't complain because we ran Magit for free that month. So, any other questions? Okay, with that, there's some related content. I know most of these sessions are already finished, but if you watch this online or you want to have some other things that are related to this session, just go there. You can. It's quite a big hallway, but you can find me in the hallway if you want to chat about something or ask a question. With that, thank you for being here. Thank you for coming to TechEd. Thank you for staying so long on this last day of TechEd, and I hope to see you soon. Please do not forget to join the contest. Although I should actually say, don't join this contest. I want that Aston Martin. And there's some resources on Channel 9. You can learn more at microsoft.com/learning. There's MSDN accounts you can subscribe and win an Aston Martin. And please evaluate this session. Thank you.